Hi, everyone. This talk is going to be about Dagger Reflect from runtime to compile time and back again. A little bit about me. I've been doing Android for about 9 years. I like chocolate and running. I previously used to work at Square NSF on Square Register and build tools. I'm currently working at SoundCloud in Berlin. I'm also the maintainer of Fladle, which is a Gradle plugin for Firebase Test Lab. That makes it really easy to run your tests on Firebase Test Lab. And I'm studying a new Gradle plugin called the Gradle Doctor, which is super fun, but not for this talk. All right, so before I explain what Dagger Reflect is, we need to understand why and how we got here. So let's start with a brief history of dependency injection. So if you have a simple class like this that depends on, you have a store and it depends on an item, the way you would implement dependency injection is you would pass the item into the constructor. And that's just very simply the dependency inversion principle. But in Java and Android, we build all these frameworks to solve these complex challenges that happen as you scale up this very simple problem of passing something into the constructor. And dependency injection in the Android world actually started based on frameworks that were built to solve the constraints in the server world. So it started, these server frameworks like Spring were built to solve a different set of constraints. So Spring, if anyone's ever used it, used these really fun XML bean constructors to build classes. And this was the state of the art of dependency injection at the time because it was way better than manually creating your classes. And then Java 1.5 came along and created annotations. And Juice took these annotations and you could stick them on your constructor, and then you wouldn't have to write all this XML boilerplate. And that was then the state of the art. But as we moved to Android, the constraints changed, and we're running on small, lower-powered devices. So Dagger came along and created, and Dagger would generate some code based on these annotations and these modules. And it would find all your object graph at runtime as well as at compile time to make the app start up faster. And then Dagger 2 came along because the set of constraints changed. Now we really, really did care about app startup time. We wanted to do everything at compile time, and we wanted to get feedback on our errors faster, and we wanted to do that at compile time. So we added these annotations and components, and that was Dagger 2. So if this is a super rough comparison of, this is not like, okay, Juice is 100% runtime, Dagger 1 is like half compile time, half runtime. That's not really what it is. It's just to show you that Dagger 2 does almost everything at runtime, and Dagger 1 does some things at runtime, some things at compile time. So, well, what's the problem there? Problem is, as Android apps became more and more complicated, we run into a problem. If you look at this build scan, which took 59 seconds, it spent 41 seconds in annotation processing. And that's a lot of time. So now we don't care about the user's time, we care about the developer's time. And that's the next set of constraints for dependency injection frameworks. So that's where Dagger Reflect came along. Dagger Reflect is a reflection-based implementation of Dagger, the dependency injection library for fast local builds. I should emphasize, it's only for local builds, not for production. All right, so how does it work? So if you have an application class that's called myApplication, and it depends on the Dagger application component, just so you understand what the code looks like, this is what the application component would look like. You have your component annotation on top. And at the bottom, you have your application class. And then the way you inject all the things you want to inject, you add an inject method to the interface. And then you call inject from your application class. And this is what your, this is what your application class looks like. And that Dagger application component you see there is this massive, massive class. In our case, it's over 10,000 lines. On the next slide, you'll see a little bit of what that looks like. It's really, really long. And generating all that code takes time. And that's why Dagger is slow at compile time. But so what does Dagger Reflect do? It takes that huge 10,000 line thing and it swaps it for something that's about 20 lines long. At least in our case, it was 20 lines long. And that calls into the Dagger Reflect runtime. So you basically can do a little switching back and forth here. You're using the same interface, the Dagger application component, but one calls into Dagger Reflect, which is generated by Dagger Reflect, and the other one calls into the generated code by Dagger. Let's talk about how Dagger Reflect works. So this generated code, there's a bit of glue that Dagger Reflect creates to link the generated code with to link your app's written code with the Dagger Reflect runtime. And that's done by the Dagger Reflect annotation processor. So we're trying to get rid of annotation processors, but we need a little bit of glue to make the magic happen. So let's take a look at what that magic looks like. This is your generated Dagger application component generated by Dagger Reflect. As you can see, you have this factory method in it, which is the same method. This is just on the public interface of your Dagger application component. This was the method that was annotated with at factory earlier. And you can see this calls directly into the Dagger Reflect runtime. The Dagger Reflect runtime has a class called Dagger Reflect. And what does that do? Here's the public interface of that Dagger Reflect factory class, and it calls into the component factory invocation handler. What is a component factory invocation handler? It sounds really complicated, but really what a component factory invocation handler is an invocation handler. And as the name would suggest, what that does is it handles invocations on a class. So basically, anytime you call into another class, it passes through the invocation handler. In this case, this is how, this is just in the java.lang.reflect package, this is what the invocation handler interface looks like. In this case, we're handling method invocations on proxy classes. So this is similar if you've ever used Retrofit. Retrofit also works uses invocation handlers on proxy classes. It uses a proxy class to handle invocations on your Retrofit interface. In this case, we're using a proxy class to implement our Dagger application component. So a proxy class in Java just implements interfaces at runtime instead of implementing it at compile time or when you're writing the code. So yeah, in this case, we're just implementing our component interface. And here's a little diagram of how that works. Your application calls into the Dagger application component factory, which proxies calls through the component factory invocation handler, and that calls into your Dagger application component. Those are really long words, but when you're using it, you don't really need to worry about it. This is just all the magic that happens underneath the hood if you're really curious about it. So anyways, stepping back into how that component factory invocation handler works. Well, actually, how does Dagger Reflect works? Stepping away from the component factory invocation handler. So it calls this for component factory method. And what that does is it builds your object graph based on the component factory you passed into it. And let's walk through this method one at a time. So the first thing it does is it reads the annotation on the top of your component factory method. This is basically doing the same validation that Dagger would do at compile time, but at runtime. So it validates that you have the proper annotation on that class. The next thing it does is it checks that the annotation is inside a component class. This is because you can't you can't just stick a factory annotation on any method. It needs to be inside your Dagger component. So that's what this check does. And then it creates the proxy. How does it do that? Well, first it passes in the factory class. Then it creates a new component invocation handler. It gives it the name of your component class that implements your Dagger interface. And then you give it a component scope builder, which is another method that's part of the Dagger Reflect library. Let's take a look at the component scope builder. It actually looks really similar to the component invocation factory handler. First thing it does is it checks that proper annotation is there. The next thing it does is it reads any scoping annotations. In this case, if you have a singleton annotation or any other scoping annotation on the component. And then it passes that into the create along with all the modules it declares and any dependencies. All right, so next part of this talk will be on how to develop Dagger Reflect, or how the project is set up. Because I think it has a really cool project setup, and let's talk about it. Whoop. Flipping through my slides really fast here. So there's 4 Gradle modules in Dagger Reflect. There's the Reflect package, there's the Reflect compiler, which basically glues your written code with the Reflect runtime. Then there's also the integration tests. Sorry, the code gen is what generates the code. Anyways, I'll talk about all 4 of these in a sec. So first, let's talk about the Reflect compiler. The Reflect compiler is what generates the glue to link your code to the reflection-based Dagger implementation. The integration tests are where the meat of this project happens, though. The integration tests make sure we do exactly the same thing as Dagger. And how do we do that? So this project isn't a UI. It's not an SDK. I mean, it sort of is an SDK. But how do you manage an open source project where there's people all over contributing to it, and you want to make sure that you're doing the exact same thing? So this project is unit test driven with the integration tests. And the integration tests look like this. You have a component, and every test basically creates a little component and then just tests that you can get that dependency. And then you just assert that that dependency was what you expected it to be. But what is this backend here? So the backend is what calls into Dagger and creates the object graph. In this case, there are 2 implementations of it, and it's run as part of a parameterized JUnit test. Backend.values is actually an enum with 2 values, the reflect and codegen. So in this case, reflect would be Dagger Reflect, and codegen is regular Dagger. And what this does is it allows Dagger Reflect to run every single unit test amongst both backends very easily. And that ensures that Dagger Reflect and Dagger have exactly the same behavior. And how does that work? Man, my clicker is not working. Anyways, okay, so this is the implementation of that backend, that backend enum. One version of the enum, when you call create, it calls Dagger Reflect.create, The other one calls Dagger CodeGen.create. And so now if you take a look at this parameterized test again, it makes sense what that's doing. And if you take a look back at the test, well, you can see that you don't have to worry about every test running both versions of it. It just sort of works, which is really cool. So if you want to contribute to the project, the way you do it is you write a test for some new feature that maybe doesn't work. And then you add a line called ignore reflection backend if this feature doesn't yet exist in Dagger Reflect. So in this case, this is a test that makes sure that just-in-time generic provides methods that are nested work. In this case, they are supported in Dagger, but not yet in Dagger Reflect. So you add an ignore reflection backend line. And what does that do? It's a JUnit test assumption, and it basically just skips over the test if the backend is reflect. And then what's cool is once that feature is built, you just delete that line. And then all the tests continue to work. But there's another part to the integration test module, and that is the upstream tests. And this is really cool. It is basically a submodule that contains all of the Dagger tests, and it runs all of the Dagger project's tests in a submodule against Dagger Reflect. But of course, there are some tests that are filtered out for different reasons. For example, the reusable annotation has a different behavior in Dagger Reflect. Because there's no guaranteed behavior in Dagger of how the reusable annotation is used, Dagger Reflect just tries its best to not create too many instances of whatever you have as reusable. So anyways, that test is filtered out because it doesn't have the same behavior. Also, things that aren't implemented yet in Dagger Reflect are just ignored using this test filter. All right, so now you're wondering, Dagger Reflect sounds cool and super complicated, and you're totally boring me, Nelson. How do I use it? So the first thing you want to do, okay, I'm gonna just not use my clicker. Okay, first thing is make sure to use the component.builder or the component.factory methods. This is just general advice for using Dagger. If you don't have a component.builder or component.factory method in your application component, you probably should because it's just safer. It looks like this. There's all sorts of blog posts on how to use it, explaining the safety of it. But yeah, just make sure you have one of these guys. And then this is what your application looks like when you're using that factory method. So that's the first step in using Dagger Reflect. Second step is to make sure all your Dagger annotations in your code base have runtime retention. So this would include both your qualifier methods and your map key annotations, as well as any other custom qualifiers you have. So the way you do that is really simple. You just take @retention runtime. In our code base, I also created a structural-based search inspection, which is not very useful these days because most of our code's in Kotlin and these only work in Java. But there is now a lint check in the Dagger Reflect project, which I'll get into a bit later, that will give you the same warning. And then the last thing is you want to swap all your dependencies on Dagger for all your Dagger Reflect dependencies. So how do you do that? This is where the Gradle fun begins. So let's say you have a module that depends on Dagger and the Dagger compiler. Looks like this, and you're using capt. First, you want to create a function to switch between the two, and you can use a Gradle property. And if you set this Gradle property to true, then you should use Dagger Reflect. This is kind of like a very simple version of what we have in our code base. So then this is what your build.gradle file looks like for that module. So if, where we had before, if you're using Dagger, if you're using Dagger Reflect, use the Dagger Reflect runtime as well as the Dagger Reflect compiler. Otherwise, just use regular Dagger. The Dagger Reflect runtime is the code I was referring to earlier that actually creates the proxy interfaces, and the Dagger Reflect compiler is, of course, the code that glues your application with the Dagger Reflect runtime. And that is code generation. It's using capt in this case. So if you have a project with hundreds of modules or maybe thousands of modules, you need to do this in every module, which sounds like fun, but it gets more fun. So let's say you're using the Dagger Android runtime. So now your little block of code looks like this. The extra line for the Dagger Android, because you don't need the Dagger Android compiler if you're using Dagger Reflect. Dagger Reflect also includes the Dagger Android stuff. So yeah, you have to swap Dagger for Dagger Reflect in every module and for Dagger Android. And there's one more thing. If you also want to have the fun Dagger Reflect lint checks, you also need to add that line in the chunk of code. So yeah, just anytime you add a module and you have thousands of developers, just do all those things and it works great. But no, that's really annoying. That's really high maintenance. But it would be a shame to let such a high potential project be underutilized by the high maintenance costs of writing all those build.gradle files for every single module. So, but that's repetitive tasks, and we're programmers, so we program away those repetitive tasks. And we made a plugin. It's called the Dagger Reflect Gradle Plugin. And all you have to do is apply it to your project, just like that. That's really all the code. And then you can add the Dagger Reflect property, set it to true in your Gradle home, not your project, so you can control it for local dev builds. And so what, so yeah, that's pretty much it. It's super easy to use. Let's talk a little bit about how this Gradle plugin works. So what this Gradle plugin does, once again, is it switches from Dagger to Dagger Reflect. And this is basically the entire plugin. It sounds super complicated, but I'll walk you through it one by one. First thing it does is if it detects a module, so this uses the Gradle dependency substitution API. The Gradle dependency substitution API basically just lets you swap any dependency for another dependency. You can swap one Maven coordinate for another Maven coordinate. You can swap Maven coordinates for projects in your local build. You can swap Maven coordinates, you can do the other way. Anyways, lots of fun. So anyways, if it detects that you're depending on the Dagger runtime, it also adds the dependency on the Dagger Reflect runtime. That's basically what this piece of code is doing here. The next part is under the dependency substitution API. If it detects that you are depending on the Dagger compiler, it swaps it for the Dagger Reflect compiler. And then it also does the same thing for the Dagger Android processor. It swaps it for the Dagger Reflect compiler. It doesn't actually need to add the Dagger Reflect compiler because it should have already been added. But it just removes the Dagger Android processor from the compile path. And yeah, that's the whole plugin. So you're wondering, what is the current state of Dagger Reflect? So first things first, you're going to have a slower startup time. In our app, the startup time went from like 3 seconds to like 7 seconds. So watch out. Second thing is it does lazy reflection. What this means is it doesn't scan the entire app at startup. So you can have broken pieces of your object graph because it's not doing validation. The trade-off is to have a faster startup speed. So basically, it's doing lazy reflection to save startup speed, but it's not scanning your whole object graph. Third thing is it has different behavior than production. Because it's using reflection, things are going to work differently. It's going to be slower, things like that. The other thing is not all Dagger features are supported yet. There's no real list, but just try it out. It's getting pretty close to supporting all the things that Android projects would probably use, but maybe not at if you're doing crazy things with Dagger. And then fifth thing to know is the error messages in Dagger Reflect are not that great yet, but it's something that we're working on. All right, what is the future of Dagger Reflect? Obviously, match Dagger with features, improve error messages. But also there can be some runtime performance improvements if that's really something that slows down your app. And then there's also some experimental branches with Kotlin Dagger Reflect. This is interesting because if you have a pure Kotlin code base and you're only generating Kotlin code, you can have faster build times than if you have a mixed Kotlin and Java code base, or if you're generating mixed Java and Kotlin code. There's, and once again, this is just like a bar graph I threw up just to kind of compare. Uber did a blog post comparing the different performances of annotation processors. So first one at the top is if you have Java generating Java code only, that's obviously the fastest build. And if you have Kotlin generating Kotlin code only, that's a little bit slower. But if you have mixed Kotlin and Java generating mixed Kotlin and Java, then that's the slowest. So if you only have, if Dagger is your only annotation processor that's still generating Java, and you switch it to Dagger Reflect, and Dagger Reflect generates only Kotlin, then you could get a little performance boost. But anyways, these are just some pie-in-the-sky ideas for Dagger Reflect. It doesn't quite do that yet. So how do we use it at SoundCloud? So it was a long-running 20% project of mine, but it was shipped to master in July, so we've been using it for, 4 months now? Yeah, 4 months. We have a fork of Dagger Reflect with the supported features we needed. It's a fork on a pull request, so the code is out there. And devs can opt in. All they have to do is add dagger.reflect equals true to their Gradle home, Gradle properties, and then it works. But what about your projects? So Dagger Reflect is at 0.1.0 if you want to go ahead and use it. Dagger Reflect Gradle Plugin is also at 0.1.0. There have been a lot of changes recently. We should probably push out an update to both of these soon. So like the lint check I mentioned is not in these versions, as well as the internal fork we have. But keep bothering us so we can push ahead and release the things. Okay, so it was fine and dandy. I shipped this thing to master, and then I added a property to our build scans to track whether people were actually using this. And it turns out nobody was using it except for one person on our team who I was like, come on, try it out. So why is nobody trying this? Like, it makes your build so much faster, right? Like, look at this build scan, right? It was a 5-minute, 44-second build. This is a real build from someone's machine. And on that build, it spent 3 minutes and 22 seconds in annotation processing. What if that 3 minutes and 22 seconds was 0? Thing is, like, when you get a build, no one like clicks that build scan buttons. So I pose the question, would it be possible to print the amount of time spent in annotation processors immediately to the console, just like the build scan plugin does? The answer from Tony was, the build scan plugin is not open source. But that doesn't stop us. You dig into the a.b.c. a.b.c, there's a compiled Java data source that calls A obviously calls C calls B, B.c, event sync. What's going on here? B, or A, has annotation processor details. Let's take it. So we took the annotation processor details, and we print them out to the console. So in this build spent 32 seconds in annotation processors, excluding capped. So I should mention, we have a lot of our modules use the Java annotation processor, not the Kotlin annotation processor, for build performance reasons. So this could actually represent a much larger portion of your build if you're using the Kotlin annotation processor, because it's much slower. But it's harder to measure the amount of time that capped spends, because the build scans actually don't measure Kotlin annotation processors. So, yeah. Once I started doing this and printing it to the console, a lot of developers started switching to Dagger Reflect. It was kind of funny. So anyways, let's talk build scans, or let's talk build times. Obviously, I showed this slide earlier. There's like a 59-second build. It spent 41 seconds annotation processing. There's this like 2-minute build I had that spent 1 minute annotation processing. And then, yeah, this one from the earlier slide, 5 minutes, and it spent 3 minutes annotation processing. Basically, like, the longer the build, the more the time is actually from Dagger annotation processing. And the thing is, when you're using Dagger Reflect, that number is, the amount of time spent in Dagger annotation processing is 59 seconds. But is this a trade-off? We're using the Gradle dependency substitution API. Are we substituting these really, really long builds at the sacrifice of shorter builds? And so you can create all these synthetic benchmarks that show the data that you really want to show. But I find that they're not really trustworthy. Although, I made some synthetic benchmarks, and if you make a change in our module that runs the annotation processor is like 15 seconds slower, which represents about 25% faster for that module. What's the real world performance numbers? That's what really matters. So I should say this is not an A/B test. This is not scientific. But according to our numbers in Gradle Enterprise, for all the builds where in the past 4 weeks, with Dagger Reflect is off, the average build time was 58 seconds. In the past 4 weeks, with Dagger Reflect on, all those builds, the average build time was 47 seconds. This is, of course, only for developers who are opting into that. But that represents approximately 19% faster builds. And that's pretty fast, considering all you have to do is apply a plugin to your project. That's probably the biggest win you can get in your build speeds. And what's also interesting about these numbers is that since Dagger gives you faster feedback by failing the build right away, it's actually, the numbers we're measuring is, it's really hard to really understand, are you making developers' lives better? Because Dagger gives you the feedback during compile time and then decreases your build time, right? But if you have an error with Dagger Reflect, you notice that error at runtime, and you have to wait until the app starts up. So, I don't know. But there's a number you can show and say builds are 19% faster. So, yeah. Anyways, I must thank a lot of people because there's a lot of people to thank with this. Ricardo on my team for helping me test Delect and help with open sourcing projects for the first time. It's a thing. Thanks for my team, of course, for testing out Dagger Reflect, and SoundCloud for letting me have the time to work on this. And also, Jake Wharton did the bulk of the work on the Dagger Reflect project, and also helped me review some code submissions I had to Dagger Reflect. And he also built and released 0.1.0 right in time for the last time I presented that talk, so gotta thank him for that. If you want more information on annotation processors, I can really highly recommend this talk by PY. There's also links to Dagger Reflect, Dagger Reflect Gradle Plugin, and also a brief history of dependency injection. But that is the end of this talk.